Hello, everybody in the room and those from the future watching on YouTube. My name is Emily Taylor. I am an engineer in the engineering team at Octopus Deploy, and my job is to write code and ship it. And so as part of that, I write unit tests. I've been involved with NDC, but for a number of years, starting as an attendee in London and then for a number of years volunteering in Sydney. And this is my first time speaking. So I'm not nervous, you're nervous. I'm not by any means a testing expert. I'm just somebody who writes tests as part of doing their job. So this is unit testing deconstructed. It's based on a lot of things that I've learned over the years from some great talks at NDC. I encourage you to check out all of my sources because they've really helped me. I've got a QR code there that you can scan to look at these slides and get links to all of them along the way. Because checking your sources is important, as you'll learn in this talk. So get my slides. Let's focus. There we go. I want to start by framing this. When we all start learning about unit tests or writing them, there's some things that we generally come across on the way. They're sort of unavoidable, some definitions, and I'm going to look at each one of them in turn and look at where they come from. And the first one, of course, is what a unit is. So I think if we frame this, we can all sort of start by agreeing that a unit is generally a piece of code with one responsibility or one reason to change, right? And then a unit test is just simple. It's something that tests that one unit. And we have mocks, things that isolate our unit under test, which is important because we want to test that one responsibility or one reason to change. So that's all some stuff that we generally agree about unit tests, right? And here's a unit test. It's a fairly contrived example. It's something that fits on one slide. Maybe it needs a bit of a refactor. That's a whole other talk, but let's go through this step by step. So we have an arrange. We're setting up a unit under test, in this case, our conference. And in order to get there, we have some entities that we're mocking out and some services that the conference relies on. Then we're acting, we're testing a behavior, we're RSVPing Joe to the unit testing talk. And then an assert. So we're checking that Joe has been added to the attendees list. So this is a unit test. But let's look at what a unit is again, right? Let's go into this in a bit more detail and we'll do this for each along the way. Does anybody have what?
Hey, Emily, we lost your sound there. We can't hear you.
Damn, can you hear me now?
Yes.
Slide deck. Oh, technical difficulties.
No worries, that's unfortunate. We were just up to the slide where you said we're introducing solid. So just to go back to that point.
Okay.
It's all part of the experience, you know, having the difficulties.
Thank you all for bearing with me. Are we back now?
Yeah.
Okay. Okay, so we want to look into this idea of a unit in more detail. So does anybody have what they'd call a solid understanding of where the concept of a unit comes from? I am, of course, talking about the single responsibility principle. And if you want a great talk about where all of the solid principles come from, deconstruction, I recommend this one by Kelvin Henney. He goes through each of them in turn. And if you look closely there, there's a hint about where the name of this talk came from. So, when we first learn about the single responsibility principle, we all come to it. Maybe we've read a book about it, or maybe a colleague's mentioned it and we have no idea what it is. So maybe we Google it and end up here on this website with the form of all knowledge. And then we might learn that the single responsibility principle is when any module class of functionality or function has responsibility over a single part of the functionality. And that term is based on a principle of cohesion, and it was introduced by somebody called Robert C. Martin. I hadn't heard of this person referred to as Robert C. Martin before. And when you're on Wikipedia, it gives you links that link to links that link to links. So I learned that Robert C. Martin had done quite a few things. Like, he was involved in some pretty important decisions around the turn of the century, had his name on some important documents. So I could probably take his word for it, right? This principle of cohesion I have responsibility over one thing. Well, I'd had it recommended to me to go ahead and go back to the source. So I went ahead and got a version of structured analysis and system specification. And that's actually more effort than you need to go to, because it turns out that this book that was written in the 70s is keyword searchable on Google. So you can look through the whole thing and find for yourself that there is actually no mention of single. In fact, there's only one page that talks about cohesion in general. And I think if Tondnako meant for it to be a principle of cohesion, he would have mentioned it, because he's a pretty straight talker. What he does say is that cohesion is a measure of strength and association between elements inside a module. A cohesive module is one that should be treated as a whole, because it's closely related. It attempts to divide it, increase coupling and decrease. And then following on from that, some great advice that I've had is to look at this post by Glenn Vanderberg, where he gives us some great words around cohesion that I use all the time. He says the cohesion comes from the same root word as adhesion. It's a word about sticking. Things that are adhesive have a one-sided external connection. It's like gluing things together that don't belong together. And cohesion is things that naturally stick. They're like-kind, they fit well. So I've had pair sessions where we've looked at some code and gone, oh, that looks really adhesive. Can we break that apart? Or there's a few things here, but they're really cohesive. I think it would increase our coupling if we started moving things around. So how are we all doing? We started off with this question of what is a unit. We thought we knew what it meant. Now we've looked at some sources, right? And it's the ground's sort of moving underneath us. So what is a unit? It's a cohesive module, a class or a function. It's a set of one or more responsibilities that should be treated as a whole. Okay, so how's this sitting with everyone? Because, we're starting to challenge some really fundamental ideas, right? And I hear you, because what about TDD? The single responsibility principle, the idea of a unit, that's one thing, but test-driven development has always told us to test one thing. This is a best practice that we've all come up with. Is doing. We have a behavior that we're testing, and we're isolating out one unit in order to test it. We've got our mocked out DB, and we're getting rid of all of the services except for this conference that really care about behavior. But we've become really tightly coupled to our code structure here. We've got all these constructors and method calls. If any of those signatures change, then our test breaks. And I don't know about you, but when I see this test in a code base, it's never just one. There's tens or hundreds of these, testing every combination and permutation. What happens if Joe tries to RSVP when there's no room left in the session? What about if there's 2 cases left? Anything like that. But that's test-driven development, right? Like, this is a practice that we're trying to uphold where we only test one thing. And we all come to test-driven development in different ways. Maybe a colleague told us about it, maybe we read a book. But if we'd never heard about it before, maybe we'd end up on this site, Wikipedia. There we would find that it was a term introduced by Kent Beck, who's credited with rediscovering it or developing it. And it's based on a book, I think you can see where I'm going with this, called Test-Driven Development by Example. And again, we hear that it's about testing one group of functions or a module or a class. So I went ahead and got test-driven development by example. Again, keyword searchable. And again, there's no direct reference to testing only one thing. And again, I think Kent Beck is fairly exhaustive. When it comes to test-driven development, he talks about everything, what sort of chair you should be sitting on, what sort of big desk you should have your computer on while you're doing test-driven development. So I think if it were to come up, he might have mentioned it. What he does talk about, and this is from the foreword, and it's got some familiar words in it, is having highly cohesive, loosely coupled components to make testing easy. It's a nice to have. What he sets out to do is to test a behavior. He wants to demonstrate confidence that we have something computing correctly. And again, for me, the source that I looked into to learn all of this was Ian Cooper in a talk called TDD, Where Did It All Go Wrong? I think Ian did some workshops earlier in the week. Ian, I don't think you're here at the moment, but you're my hero. You've changed the way I write tests. And Ian has a summary of TDD by example, which I agree with. And I hope I do it justice here. But what some of the broad strokes that TDD by example goes through is test behaviors, not implementation details. Test from the outside in. This one I'm super passionate about. Start from your use cases and only work down to the more specific granular test cases when you find more specific behaviors to test. And focus on testing on the public API at your chosen abstraction level. That's not necessarily to say a REST API, right? I'm talking any public API, any class, module, or function that you're working on. Only test the public details of that API. So we've got a metaphor here. We can think about it as peeling back the layers of the onion, writing tests inwards as we go. Okay, time for another check-in. We've gone through unit. Now we've gone through unit test. How's everybody feeling? What do you think at this point is our new definition for what a unit test is? Well, would it surprise you to know that according to Kent Beck, the guy who literally wrote the book on it, it's a test that runs in isolation from other tests. That's it. As long as you can run them in parallel, if you've abstracted away your services that are integrations, you have a unit test. Now, all of this you might be saying is based on books from decades ago or back in the 70s, right? Maybe the conversation's evolved. Maybe we've moved on. Maybe there's good reasons we don't think about this that way anymore. Well, it turns out here's Kent Beck last year, end of last year, saying tests should be coupled to the behavior of code and decoupled from the structure of code. And he's seeing tests that fail on both counts. So these ideas are still sticking around today. And this generated some conversation, right? There was almost 600 people responding to this, people tweeting it, retweeting it, liking it. So Kent followed up with a blog post called Test Desiderata. And this is sort of my guiding light now for writing unit tests, which I really recommend. If you take one thing away from this talk, I'd say have a look into these Test Desiderata. And there's 12 of them. They're all in the blog post, and then each one has a YouTube video just to go through it in a bit more detail. I'm going to talk about 4 here today, so we can compare them to that test we had earlier and look at how it stacks up. So first one, behavioral. We want our test cases to be sensitive to changes in the behavior of our code. If behavior changes, we want our test result to change. On the other side of the coin, we want them to be structure-insensitive. Tests should not change if the structure of the code changes. And isolated, they return the same result regardless of the order in which they are run. And writable, we also want them to be cheap to write. We don't want to spend all of our time writing our unit tests, right? So practically, what does this mean for our unit test that we've been looking at through this talk? Well, we're definitely isolated. I think we can say that for sure. Not only are we extracting our integrations like the database with the mock, we're also mocking out absolutely everything else except for the one class that we're trying to test. But as a result, we're not structure insensitive, but we are structure sensitive. And we're behavioral. We have a test case here, and if the behavior changes, if we change the code so that this no longer happens, then our test will break. So that's good. But I would definitely argue it's not writable. Like we talked about before, we have many of these cases that would break if something changes. Another thing to consider is that in each iteration, when setting up those mocks, it can be difficult to manipulate those to be specific to each test case. So I think what we're sort of barreling towards here is this question: do we always have to make trade-offs in the sort of the desirable qualities that we have in our unit tests? And my answer to that would be yes, we do have to make trade-offs, but we should aim to minimize the number. And we can do that through refactoring or changes in tooling. Here's an example of another way to rewrite that same unit test. I'm not saying it's a better way or even a good way. I'm looking at it to compare what the changes have done to our desirable qualities in our test. So here we have a test that's registering a mock database. So we've got that integration layer abstracted away, isolated out. So we're isolated. We're registering real services though, and we've started using a real session provider, attendee provider, that sort of thing. And that's okay, because as we learned, a unit test doesn't necessarily mean just testing one thing. In this current code base, everything to do with that conference under test is implemented in a fairly tightly coupled, cohesive way. We've also done something to our entities here. You know, we still have constructors for them that might change at any time. But in order to sort of minimize the places that test breaks, to reduce the structure sensitivity, we've added a layer of indirection with a builder class, so that when that constructor changes, it only breaks in at once across our entire test suite. So now we've got something that's hitting all 4 of our goals. It's writable, structure insensitive, it's behavioral, and isolated all at the same time. But please don't take away from this that Emily Taylor said to use those tools. I am saying to look at these desirable qualities, the test desiderata, and decide what trade-offs you want to make. Because while we maybe achieved those 4, maybe we made something that's less readable. And that's another important goal. Maybe it's not as fast as the other test. It's worth looking into and trying to optimize it for as many test desiderata as you can. So back to where we started. Let's have a look at these things we know about unit tests now with everything we've taken on board. we have a unit, which is a cohesive collection of one or more responsibilities. We have a unit test, which tests a behavior isolated from all other tests. And then when it comes to tooling, we have these test desiderata to consider. And then once we've decided what we're optimizing for, then we should reach for tools. And most importantly, out of all of this, check your sources. I would encourage all of you to not take my word today, but to go back and check all of these links and learn and take your own interpretation away. Thank you very much. That's unit testing deconstructed.